Hi, everybody. Brad Toffel with the Internet Archive web group. I've got a lot of information to cover, so I'll go kind of quick. Feel free to interrupt me, though, if you do have questions along the way. So things I'd like to talk about, just a quick overview of the overall web group, talk about some of the technologies and the formats that we use for doing web archiving. I'll talk about the current global Wayback machine that you can see at web.archive.org. I'll talk about the new open source Wayback machine software, which I'm the principal developer on, some of the technical challenges involved in building the system, and then talk about what's coming down the road for the project. So the Internet Archive Web Group is a technology partner for web archiving. So there's national libraries all over the world that have started using us to do contract crawls for all of .fr, for example, or all of .au. The British Library, the Library of Congress, so crawls of all of .gov. So large-scale web archiving. We have a part of the web group is a team devoted just to doing that sort of activity. We do preservation and hosting for some of those collections. We've got a service called Archive It, which might be very interesting for some of you who are interested in doing web archiving at smaller scales, where this would be submit 5 seed URLs or 50 or 100 seed URLs about a particular topic. Perhaps it's your university's website or just one of the departments, and say how often you want the service to crawl it. And every week or every month or every 6 months, we'll do a harvest of the seed URLs going to some predetermined depth. We'll actually provide a Wayback service that you can then use to access the archived content. We'll provide full text search on top of that. And then, of course, if you ever want to download your data, it's yours to download. The last thing that the web group does is we've got several open source initiatives. One of them is the Heritrix web crawler, which is designed to be an archival quality web crawler. So we really have gone to a lot of lengths to try to make sure that we capture everything that is part of a website. There's some stuff that's very challenging to grab. For example, URLs that are generated via JavaScript are challenging for lots of web crawlers. Nutchwax is an extension to the Nutch full text search engine, which does both crawling as well as provide full text search using, it's built on top of Lucene. So we provided some extensions to the Nutch full text search engine that allow it to read from our particular formats, and then of course the Wayback open source software. So the overview of the technologies that we use, I'll talk about the formats that we use to actually store web materials. I'll talk a little bit about the new work format, collecting. Heritrix is the open source web crawler that I sort of mentioned already. Access, indexing, and search, these are all the different sort of, we're trying to provide a sort of, from start to finish in doing web archiving, all the tools you need. There's actually one missing component, which I think is something that perhaps should be addressed in this particular forum, which would be how do you actually preserve the data? How do you store it? So the ARC file format actually goes a little ways towards doing that. The motivation for the ARC file format is if you're going to store large amounts of the web. For example, the web collection currently is about 100 billion web pages or web documents. Those are not all web pages. There's images, there's PDF files, whatever you might find in the web we've actually got. So managing all of those little individual files is just too cumbersome. So we developed the ARC file format. I've described sort of what it looks like basically. There's a metadata line which contains some information about the capture. It's the URL, the IP address that that server resolved to, the date spec, which is a 14-digit timestamp of when it was saved, a guess at the MIME type of the document for future processing to make it easier, and then the actual length of the saved content. There's a new line, and then everything the server returned, including the HTTP headers, which is actually going to be content of length bytes. There'll be another new line, and then another record, and another record. So this saves a lot on managing just the total number of files as well as for processing. Instead of spending all your time opening a file, checking permissions, closing a file, opening a file, checking permissions, reading through it, closing the file. You can open the file once and stream through the entire document. So the ARC file format, again, you just put one document after another, after another, after another. When you've reached 100 megabytes in size, you close that file and open a new ARC file with a unique name. So the number of documents in an ARC file, generally, rule of thumb is about 10,000. But if the third document you get is a gigantic video that's 200 megabytes, we'll record up at the end of the video and then close it. And there'll be 5 documents in that ARC file. So the current worldwide Wayback machine, which hopefully some of you are at least aware of, developed by Alexa Internet in 2001. It was written in Perl. It was done very quickly by a very talented developer named Dave Sherfasy, who did the whole thing in like 3 months. It was incredible. However, over the long haul, we are still currently running that version for the public Wayback service. It's proved to be cumbersome to maintain, difficult to extend, test new features with. It has scaled very well. As I said, we've got over 100 billion documents in the Wayback service right now. The service peaks at over 400 requests per second. We've had a peak as high as 500 requests per second at different times. There's 4 distinct tiers, which I'll go through very quickly, just so you sort of have an idea of where the open source software is gearing towards. So the 3 tiers here, there's an Apache service that's just running mod rewrite that reverse proxies requests to a whole farm of machines that are each doing CGI service, which basically means they talk to the backend index machines and draw the actual page you see. If you do a query, show me all the copies of Yahoo that you have. It shows all the different dates in there. It also retrieves actual documents and modifies those documents for replay, which I'll talk about in more detail later on. So I'll skip past that now. The WE server layer is actually the index layer. This is right now, we've divided the index of those 100 billion documents. It's about 15 terabytes. I'll talk about the format of that in just a second, but just know that there's 150 different servers. There's 2 copies of each of those, so that we have some redundancy in case the machine goes down. And then the bottom layer is where we actually have stored all of the ARC files, which is about 800 machines. And knowing the name of an ARC file and the offset where the document you're interested in begins, you can find the correct machine, open a connection to that machine, read the one document you're interested in out of the ARC file, and return it to the user. So CDX file format. CDX file format is the index format that we use to store the Wayback index. Right now it's just implemented as a very large sorted file. Like I said, logically it's a single 15 terabyte file. In actual production we divide that into 150 little pieces, which are each alphabetically contiguous, so that everything between apple and banana is going to be on one machine. So if you ever have any request coming in for that host or something beginning with that, you know which machine to go talk to out of the index range. So the fields within the current Wayback index, there's URL, there's the date spec, which came directly from the ARC file metadata line. There's the original host name. We do some massaging of the host names to make things easier to find. For example, if we crawl www3.yahoo.com, which is exactly the same as www4.yahoo.com, we'll just remove those in the index and treat them all as being the same. So we keep the original host name in there, the MIME type, the HTTP response code. We keep an MD5 digest of the document. If there's a redirect in the document for some of the service reasons, it's actually handy to be able to actually just send the user directly to where they would end up at without going down to the actual ARC file. And there's the name of the ARC file where the document appeared and the offset where it starts. So if you have a gigantic file, like you can see at the bottom of this, there's 4 sample lines that you might see. Actually, I did copy and paste these directly out of one of the Wayback indexes for a site, Danish.com. So the next generation Wayback machine, it's an open source Java project. It's designed to be very simple. I'll go into the sort of a very simple picture of what the design looks like at a high level in just a second. The idea of making it very simple with very few interfaces between is it's easy to then make several implementations for each of these modules. And I'll talk about some of the implementations we've done so far. It's designed to solve some of the maintenance headaches we have. When we find there's some bug that's been there for a long time, we can't get the last byte out of some binary documents that's been there forever. It'll be easy to fix problems like that, and it'll allow us to experiment with sort of new ways that users can interact with the Wayback machine and with the archived data. So here's the very simple picture of the design overview. There's the query user interface, the replay user interface, there's the resource index, and the resource store. Just to map these back to the things we just discussed in the formats, ARC file is currently how we store almost all of our web data. So the resource store is just a layer on top of that, which abstracts you off. If you wanted to store your documents in a MySQL database with the actual, as blobs inside the database, you could do that just with the new implementation of the resource store. Its job is basically say, here's a record from the index, give me the document that it came from, and there you get a stream that you can read from and return to the user, modify as it goes out. So the resource index is, again, just a direct mapping of the gigantic sorted flat file. It's just a list of what documents are actually in the resource store. So in this case, we've got 2 implementations that we've done so far. One is CDX, which is, again, just a sorted flat file. The files are interchangeable. There's some of the massaging of the URLs that isn't quite the same between the two. So they're not completely interchangeable. And then we also have a BDB implementation, which is using Oracle recently purchased Java's Berkeley DB Java edition. And this is basically a really good implementation of a B tree. I'll talk about some of the differences between those implementations in a little bit. So we've already gone through most of the components I just described, but here's some of the implementations we've got. So for the query user interface, if you look at the global Wayback Machine and you do a search for yahoo.com, you see captures for 1996 and 1997 and 98, 99 going up. So we call that the calendar mode. So we've got one implementation of the query user interface which draws a calendar exactly like the old Wayback Machine. We've got one that returns results more like a search engine. So you've just got a series of results going down the page, and you've got links at the bottom for next 10, next 10, next 100, whatever it is. Excuse me. And then there's an XML interface, which is designed to allow the Wayback Machine to be included and incorporated into other applications as a web service. So you can do queries against the Wayback Machine in open search format, get results returned to you in XML that you can then put into your own application. So the replay user interface, there's two primary modes. Archival URL just refers to how we describe URLs that are permanent that you can embed inside a web page in the live web that direct into the Wayback Machine. So of course the first host part is web.archive.org. Following that is the name of the collection, which might be web, for example, for the general Wayback. Following that you'll have a 14-digit timestamp, and following that is the original URL. So we've re-implemented the same exact way for describing URLs. One of the purposes of the Wayback Machine is to provide a reference copy in case some document has gone away on the web. We don't want to break links when we do switch over to the new Wayback Machine. So archival URL is definitely going to be a mode that we continue forward as the Wayback Machine evolves. Second mode, which is very interesting, is proxy mode. In proxy mode, you actually configure the end browser to make all requests through the Wayback service. And the Wayback is able to then receive those requests. And instead of normally proxy servers might then go out to the live web or look at a cached copy. In this case, we're looking at a cache that is the whole web archive. So this solves a huge number of problems in replay that I'll talk about in a little bit, where again you might have URLs inside the page that are generated with JavaScript that will break an archival URL because the JavaScript says go to http://yahoo.com and get the document, which makes you leave the archival URL mode and you're all of a sudden hitting the live web. In proxy mode, all requests go through the Wayback Machine. You don't need to do any kind of markup of the documents as you return them to users. Things just work. URLs embedded inside Shockwave files, Flash files, PDF documents, etc. will all just work as well. So the resource index, I spoke briefly, I mentioned there's the CDX implementation, the sorted flat file, there's the BDB implementation. We have a remote version of the resource index, which is just an implementation that all it does is assemble the query it received as an HTTP request to another server that actually does have the resource index locally. So I mentioned the query user interface, one of the ways to export the data returned to users is via XML. So this is actually used internally by the Wayback Machine to make requests to a different node that actually holds the index. This would allow you to do something like put everything between apple and banana on this machine on the index and everything banana and cow on this machine. And then your resource index on the front machine just knows how to make requests to whichever back-end machine it needs to. Unparse the XML and return results as though it came from a local copy. We've actually been doing some implementation using Nutch full text search to do URL-based lookups. Performance is not really good for larger scale for high traffic sites. But the capability is there. Wayback actually does sort of transparently shovel through whatever arguments the user's made in its incoming request. So if you were to make requests for text that the index is able to satisfy, the Wayback can return results that might look like Google search results for a text search. There's the aggregated one, which is what I explained in terms of making requests to different back-end nodes returning XML so that you could distribute your index. The resource store implementations, which is the actual collection of documents. There's a local ARC, which is a single directory holding a bunch of ARC files. There's an HTTP 1.1 remote ARC, which allows you to, knowing the absolute URL for a particular ARC file, to just use HTTP 1.1, which allows you to say, return me a particular range of a file. So if you know where that document starts at and where it ends at, you can ask for just that range remotely. Key advantage here is with the current Wayback Machine, we actually run custom software on all the machines holding the ARC data. This will let us do away with that layer and just use an HTTP 1.1 server. So here's an example of the query user interface, the calendar mode. This looks very much like the global Wayback Machine, which is by design. Here's an example of the search engine type where you just list documents one after the other. If we had more of the page down here below, you could actually see that there's next buttons, so you can see the number of results that there are and page through them. Here's an example of what the XML looks like that's returned. One nice thing about this in terms of customization for different installations, each of these 3 different screens we just looked at is actually generated with a single JSP file. And you can configure which JSP file you want to use in the overall Wayback configuration. You could also then generate your own JSP file and completely customize the way that the query results are returned. So again, we have 3 different JSP implementations. One draws the calendar mode, one draws the search engine mode, one draws the XML. So you don't even necessarily need to use the XML interface to incorporate the look and feel of your site with the Wayback software. So there's the replay user interface. Here's an example of the archival URL. I'm not sure if you can all see the URL up in the address bar there. This is 20th century find.archive.org/alpha. There's a timestamp and then the original URL we're looking at. There's some other very interesting customization things we've been doing with the Wayback Machine. This is again geared towards making it really easy to extend the Wayback and provide new user interfaces to the Wayback. In this mode, we've actually allowed you to, again with a single JSP file, as you're about to return a web page to the end user, you call out to this JSP document that you've written on your local server, which generates some HTML, which is then stuffed inside the page as it's returned. So using this, we've now got one JSP that generates a timeline at the top of the page, as you can see up there, which allows users to see all the different versions of a page and scroll between them. We've got big designs for this particular feature, this capability. We plan to do in-page presences, which is you hover over links. Might show you other versions of that particular document that may or may not be in the archive. You might have metadata about the page or annotations that can sort of just come back with the page to the end user. And again, this is all configured with different JSP files. So we've got one JSP that inserts an HTML comment that indicates this page was archived on this particular date and was retrieved from the Wayback on this particular date. And you can sort of mix and match what things you want to be returned inside the replayed documents. Here's an example of proxy mode. This is a pretty simple example. We're just looking at Google from 1998. But if you look at the address bar, it looks like you're just visiting Google, where again, any URL you type in will be received by the Wayback Machine. In this particular case, it's going to return the last version you clicked on from one of the query user interfaces. So if you click on a particular date, that sort of locks you in time to what date you're looking at. Boy, I've got quite a bit of content and not much time. So resource index implementations, the CDX implementation, which is the sorted flat file, allows for very large-scale indexes. Again, we use the exact same system to do a 15 terabyte, 100 billion document index. The problem with that is actually generating those. Building those is an external process that can be very difficult. We're actually interested in using Hadoop in the very near term to start automating that process. BDB is very simple. It scales pretty well. For lots of applications, this would be fine. It goes up to, say, 10 or 20 million documents before it starts running into problems. The really nice part is that it allows you to really easily just add new results on the fly to your index. So we've built sort of an automatic indexing script for the local mode of the Wayback Machine where you just drop ARC files into a directory. It notices these files, indexes them, and pushes them into the index, and they become live. Used in conjunction with Heritrix, as files are being written by the crawler, they could be showing up in the Wayback Machine. If you just point Heritrix to write documents at the same directory where Wayback is looking for them. So we've talked about the remote nudge interface. We've talked about the aggregated for scaled. I actually talked about all the resource store as well. I was going to talk some about exclusion, which becomes very interesting if you're not really allowed to show all the content that you've got. This is sort of follows on what Brewster was talking about earlier, is include everything and be very good at putting people out of the archive if they want to. So we've been developing a new system that allows you to block users based on if they're logged in, where they're coming from. Perhaps if they're inside the library, they can see a different set of documents. And I'm just going to click through the sort of user interface we've got for this new part. It's this exclusion oracle we're talking about that allows you to sort of associate rules. Allow, disallow, use robots from the live web to determine if it's visible to end users. Yeah, I'm not going to be able to hit all this stuff. Sorry. I'll just hit the last page. Here's some URLs. Talked about where the project's hosted on SourceForge. We use Subversion. There's a discussion list on SourceForge as well. user manual. If you're interested in archive it, that I mentioned briefly, archiveit.org. Thank you.